If you've been using AI for video-to-video lately, you know the struggle. You get the perfect motion, but the colors look like a deep-fried meme, blown-out contrast and neon saturation that just feels off. Welcome back to the Cao 2025, and today we are fixing your AI video workflow once and for all. We are skipping the old stuff and going straight to the state-of-the-art Wan 2.2 paired with VACE 2.2. The biggest headache with the older VACE 2.1 and CausVid setups was that unavoidable color and contrast shift. It was a nightmare to color grade. But with this new 2.2 update for both Wan and VACE, those problems are officially gone. We're talking perfect color fidelity and zero oversaturation. In this video, I'm going to show you exactly how to set up the Wan 2.2 video-to-video workflow to transform any source footage while keeping your colors 100% natural. Let's dive into the setup. Go to your manager, click Install Custom Nodes and search for CausVid Wan. Hit Install if you already have it. Hit Update like I'm doing here to make sure you have the latest speed boosts. Wait for it to finish, then click Restart. Once it's back up, just refresh your browser. Easy. Next is for getting all the model.
Get your models ready. First, let's download the necessary models. You can access all the links in the video description below. For the Wan 2.2 text-to-video 14B model, we're using the GGUF quantized models because they are much smaller and VRAM efficient. Access the Hugging Face link. Unlike Wan 2.1, Wan 2.2 T2 V14B uses two models, high noise and low noise. We need both. So download both GGUF files. Choose the quantization based on your VRAM. I'm downloading Q5KS for both. These models run sequentially, not in parallel. You only need VRAM to accommodate the single largest model. Place both GGUF files in your ComfyUI/models/diffusion models folder. VAE model, for T2 V14B, you use the same VAE as Wan 2.1. Download it if you don't have it already. The download link is located at the same place with the Wan 2.2 models. Save the VAE model in ComfyUI/models/VAE. Light 2V LoRa. To dramatically increase speed, we need the Light 2V LoRa. The link is in the description. Save the LoRa model at ComfyUI/models/LoRas. I'll be using rank 64 in this example. Text encoders. Finally, we'll use the Wan 2.1 text encoders. Download the UMT5 XXL PF16.SAFA tensor and save it in ComfyUI/models/text encoders.
Since we are running the GGUF version of Wan 2.2 to save on VRAM, we need a matching GGUF version of the VACE 2.2 model. This is the secret sauce that fixes the color and contrast issues we talked about earlier. I've placed the direct link to the VACE 2.2 GGUF model in the description below. Once you have that files, you need to place it in a very specific folder. Navigate to your ComfyUI directory, go to Models and then open the Diffusion Models folder. Drop the VACE 2.2 GGUF file right there. Remember to download for high and low noise model. With the models in the right place, we're ready to build the workflow. Let's head over to ComfyUI and start connecting the nodes. To make all of this work seamlessly, we are using the CausVid Wan video wrapper. I've already made a full detailed video on how to install and configure the CausVid wrapper. If you're new to this node set, definitely pause this video and go watch that one first to get your environment ready. I've linked it in the description below. Now let's build the engine. First, we need to set up our Wan video model loader. For this specific video-to-video workflow, we're going to duplicate it. One will be for our high noise model and the other for our low noise model. Let's optimize for your hardware. If you don't have Sage Attention installed, make sure to switch this setting to SDPA. Also, if you aren't running Triton, you can skip the Wan Video Torch compile setting. It'll keep things running smoothly without compatibility errors. VRAM management is key here. Add the Wan Video Block Swap node. I'm using an RTX 4060 Ti with 16 GB of VRAM, so my settings are 20 blocks for the model and 15 for VACE, with prefetch set to 1. If you have less VRAM, you might need to increase the block swap numbers. Next, add the Wan Video Set Block Swap node. Connect both your model loader and your block swap node to this to ensure the memory management is active. Now for the detail control. Add the Wan Video Low Array Select Multi-Node. Select the LightX 2V LoRa for reducing step. Duplicate it for the low noise side. For the low noise low array, I found that setting the weight to 1.5 gives the best results for keeping the original video structure while adding that Wan 2.2 polish. Make sure to set Turn the Merge LoRa option to Full. Finally, let's plug in our secret weapon. Add the Wan Video Module Select node. select the high noise VACE module and connect it to your high noise model's extra model input. Duplicate that node, switch the selection to the low noise VACE module and connect it to the low noise model loader. This specific dual module setup with VACE 2.2 is what gives us that perfect color and contrast without the oversaturation issues. Now that the engine is ready, we need to bring in our visual data. First, add the Wan Video VAE loader. Even though we are using the 2.2 model architecture, we're going to use the VAE for Wan 2.1 here to handle the encoding and decoding process. Next, we need our source material. Add a load video path node. This is where you'll select the original video you want to transform. Then add a load image node. This image will act as our visual reference, telling Wan 2.2 exactly what style or character to follow based on our source video's movement. Consistency is everything in AI video. To avoid errors, add two resize image v2 nodes. Connect your video to one and your reference image to the other. Make sure they are both set to the exact same dimensions so the spatial data aligns perfectly. Now we need to turn that video into something the AI can understand as a skeleton. We'll use a control net preprocessor. You can use Kearney, depth, or any other method you prefer, but for this tutorial, I'm using DW Open Pose. This will track the body movements of the source video with high precision. As a little tip, I like to add a video combine node right after the preprocessor. This is completely optional, but it lets you see the skeleton result before you start the full generation, so you can make sure your tracking is clean before wasting any time on a full render. Now we bring it all together with the Wan Video VACE encode node. Connect your VAE here. For the input frames, use the output from your control net preprocessor, that's our motion guide. For the ref images, plug in the image we resized earlier. Make sure the width and height match your resize image v2 nodes and connect the number frames directly from the load video frame count output to keep everything synced. Now for the sampling, add your first Wan video sampler. This is our high noise pass. Connect your high noise model here. The VACE encode output goes into the image embed input. For the text, I'm using the Wan video text encoded cached node so we can handle our prompts efficiently. Here is a pro tip for your workflow. Use a get node for your steps so you can change one value and update the whole chain. I'm setting my total steps to 8 with a half step of 4. I'm also adding a create CFG scheduler node. Watch my screen closely here. I'm setting it up so the first step of the high noise model starts with a CFG of 2 and will connect that half step value to the end step. Now duplicate that sampler for our low noise pass. Connect your low noise model. The output from our high noise sampler now becomes the sample's input for this one. Set the CFG to 1 for this pass and use your half step value, which is 4, as the start step. Pick your favorite scheduler. I usually stick with the ones that give the cleanest motion. The final step, add the Wan Video decode node and plug it into a video combine. This is where the VACE 2.2 magic finally renders out. Because we used this dual sampler method and the 2.2 architecture, you're going to see a result that is sharp, follows your source video perfectly, and most importantly has zero color or contrast distortion. And there you have it. And there you have cinematic video to video using Wan 2.2 on a 16 GB card. Here a few sample of comparison between VACE 2.1 15 frame, VACE 2.2 15 frame and VACE 2.2 after interpolate, upscale and sharpen. As you can see, there is no saturation and color change problem but for video stitching. VACE 2.2 seems have trouble of make a consistent image follow the original image, so after new video stitch it create a little change on the start image. This still bother me, but overall I think it is better than the color saturation since sometimes the change so subtle that I need to really focus on that to see it. Anyway guys, that's it for today's video. If this helped, don't forget to like and subscribe to Cao 2025. Check the description for all the model links and my CausVid wrapper deep dive, and also for the workflow. I'll see you in the next one. Please subscribe.